The idea of pharmacogenetics is being able to target the correct drug for the correct patient. So by looking at the genetic profile, we can predict which group of people will respond positively to a particular drug. And the idea is that this would become a normal part of the genetic testing that would be done by the GP prior to making a prescription available. We have a research group here working on this development of genetic analysis systems. At the moment there's about 7 people working in that area. The main focus of our work here is to develop prototypes that can demonstrate the proofs of concept, that we can do all of the steps and then try to integrate those into a system. When we then use this in a disposable chip, it means that we're dealing with nano and microliter quantities, which are replacing the larger volumes that would be used in a centralized laboratory. But ideally we want to make these chips for maybe €1 or €2. I suppose one of the things I would love to be able to do is to get this kind of technology into the developing world. People come to clinics in the developing world for diagnosis of infectious diseases, but it takes so long to do the test that they have to come back a week later. Many of them have to walk long distances, etc. If we can make a point of care diagnostic system available whereby they would get an immediate result and then they could be immediately treated as well, it would not only save them a lot of walking but also ensure that a greater success for the treatment. So one of the things that we try to do is before we make an integrated system, we try to develop it in an open platform where we can play with different things quite easily. And now while this system is actually quite large, much of the technology inside the instrument is no longer required. So in the next generation of this system, we would expect it to be much, much smaller. There's not enough awareness of both the positive and the negative aspects of nanotechnology. There's a greater need for debate about some of the nanotechnology issues. Some are already legislated for. For example, it's not possible for an employer or an insurance company currently to access genetic information, as far as I'm aware. Whereas down the road, it may be possible to put the whole genome onto a chip. And so in that case, one would want to avoid, if you go into with the flu, you don't want to find out that you have Huntington's. So you want to screen the information so that you only get the information that you require, basically, and also in terms of who accesses that information. I suppose I came from a background of zoology, where I was looking at using molecular genetics to identify salmon populations, so that we could better manage and conserve salmon populations. And then from there I started to look at the technology that has evolved now into making whole systems. So that's where I've come from.